Let's talk about centroids today. Centroids are very important, especially in determining the moment of inertia. And moment of inertia is important for determining the buckling critical force. Also very important to determine the deformation in beams. So all of these are somehow connected, and you need to know centroids very well in order to determine the moment of inertia. So let's start. When we are talking about bodies, bodies are comprised by an infinite number of particles that have some weight. So I pointed here one particle, it is a red color, and this particle has a weight dW. Then we have some other particle, which is in this case purple, I think, color, and again it is dW. They are on some distances from each other and they are parallel to each other. And the total weight of the body will be the summation of all these particles. And we can say W, which is the weight of the total body, is integral of these tiny particles dW. So when we are talking about the center of gravity, we said that it is the sum of all the forces concentrated at one point. So now, if we have this weight and we have some distance and we have some reference point, for instance at x-axis, this is reference points which we are calling datum, we can determine the couple moment around x-axis. So that will be mx is equal this distance from the force to the axis, which will be I bar, times W will give me a moment around x-axis. So what we said about W is integral of dV, which is the weight of the tiny particle. So how to determine the centroid here? If we have that moment is I bar times W, which is integral of I bar dW, then our I bar will be integral of I bar dW over integral dW. It's the same for all other axes, so you will have x bar to be integral of x bar dW over integral dW, and for z bar you have integral of z bar dW over integral dW. When we are talking about weight, we said that weight is equal m times g. So if we have some body on a, for instance, cantilever beam here, this body will have some force. We also determined that force when we said we have a uniformly distributed load. We multiplied that distributed load with the length and we had only one force. That is the same here. So we have V is equal m times g, or dV will be dm times g, which will lead how to determine the centroid here when we have center of mass of a body, which will be x bar is equal integral of x bar dm or gdm over integral of gdm, since that we have gravity above and below the ratio. We will obtain that x bar is integral of x bar dm over integral of dm. The same for y bar and the z bar. Again, we have centroid for a volume where we have that mass is equal rho times volume. And again, if we are plugging our numbers in centroid, we will obtain that dm is equal rho times dv. And then we have x bar is equal integral of x times rho dv over integral rho dv. Rho will be removed since that it is appeared on both sides, and that your centroid is integral of x bar dv over integral of dv. So the same for y bar and z bar. If we have centroid of an area, we have v is equal z times a. If z is a constant, then we have that x bar is equal integral of x bar dA over integral of dA, and y bar is equal integral of y bar dA over integral of dA. When we were talking about triangle and we had some distributed load, we point, okay, we have some distributed load, for instance 2 kilonewton per meter, and we found the force or point force, which was q times length, where this distributed load is placed, times length over 2, since that we are talking about triangle, and that was the area of triangle, and our force, which replaced this distributed load, is placed on a centroid. I told you it is 1/3 from the right angle of the triangle is the place where it is a centroid. So let's see how. Let's talk about a centroid of a triangle. If we have some triangle BH and it is placed in some coordinate axis, a coordinate system XY, we know that the equation for a line is y is equal kx plus b. Kx was a slope, and in our case we have slope to be minus h over b, and y-intercept in this case is h. Imagine that this triangle is comprised of strips in x direction. Then we will have a height, which will be dy in this case. Our area dA is x times dy. So we have y to be minus h over b times x plus y-intercept. In our case, we have x to be b over h times, in parentheses, h minus y. So instead of x, we will have bh over h minus y times dy, and that will be our area. So dA is equal x times dy. In order to determine I bar, we will have integral of I bar dA over integral of dA, and the range will be from 0 to h, because we are talking in h direction. That means we have integral from 0 to h y times b over h times h minus y, and everything multiplied with dy over integral from 0 to h bh times h minus y times dy. So how to solve this? When we are solving this, we will have integral from 0 to h yb minus y on square b over h times dy over integral from 0 to h b minus b over h y times dy. Solving the integral, we will obtain that it is bh squared over 6 over bh over 2, which in this case is h over 3. So the same situation for x, but in this case we will obtain that x is equal b over 3. So that was an example for triangle. If we have some parabolic section where we have that y is equal x on square, and we have the range for x between 0 and 1, and the range for y to be between 0 and 1, and imagine that we are using the tiny particle, which will be dx with the length of y bar, then our area dy will be dx times y, which in this case, instead of y, we will use x on square dx. So how we will determine what will be the x centroid or x bar? That is the integral from 0 to 1 x times dA over integral from 0 to 1 dA. That means we will have integral from 0 to 1. Instead of a dA, we will put x on square dx times x, and we have over that one over integral from 0 to 1 x on square dx. So that means we have integral of x on cube dx over integral from 0 to 1 x squared dx. If we are solving this, we will have that x bar is equal x on 4th over 4, and all of this over x on 3 on cube over 3, and the range is from 0 to 1. That means we will obtain that it is 3 times 4, 3 times x on 4th over 4 times x on cube, which in our case is 0.75 times x, and since that x is in range from 0 to 1, we will get that x bar is equal 0.75. The same situation for y bar. We will have again some integral from 0 to 1 y half dA, and we said that y is equal x on square. Instead of y, we will put x on square over 2 times, instead of dA, we have x on square dx, and we have again, we are dividing that with the integral from 0 to 1 x on square dx. When we are solving this, we will get x on 5th over 10, everything divided by x on cube over 3. That means when we are solving this, it will be 0.33 x on square, and the range is between 0 and 1. So the final solution will be 0.33 meter. So this will be one parabolic section. Take care about this, because this is, in this case, the only applicable solution will be integration method. When we have a composite section, we will follow the rule that centroid y bar will be sum of all centroids y times area of all these basic shapes over the summation of all the areas. What that means for you? If we have something like this composite section comprises of one rectangular section and one triangle section. And for this rectangle, we will have centroid to be 2.5, since that we have rectangle 5 times 6. That means x will be 2.5, and in y direction we will have 3. Regarding to triangle, we have 1/3 from the 3 is 1, and plus 5 from coordinate axis, we will have 6. And in y direction, it will be 1/3 from 6, which is in our case is 2. Area of rectangle is 5 times 6, which is 30. And for the triangle, it is 3 times 6 over 2, which is 18. So we have the next row, 8 times x times area is 2.5 times 30, which is, I think, 75. And the other one will be 3 times 30, which is 90. For the other section, we have 54 and 18. How to determine x bar? We have 75 plus 54, and we are dividing with the two areas, 30 plus 9, which is 39. The same stuff for y bar. We have AY, which is for the first shape 90, and for the second shape 18, and the area of the two shapes is 39. When we are talking about composite sections, we need to split in a basic shapes. The basic shapes for you are square, rectangle, then you have triangle, you have a circle, etc. So for rectangle, your centroid will be half in a x direction, half in a y direction. If you have a triangle, we are talking about 1/3 from the right angle from the both sides. So you will have b over 3 and h over 3. When we are talking about circle, your centroid is the point of circle. When we are talking, I don't know, about half of circle, you will have in x direction it will be x half, but when we are talking about y direction it will be 4 over 3 times pi over r. So that is the basic shapes, and the majority of these basic shapes you can find in FE booklet and you can find in your textbook. So this was the example of composite section, and the main focus is integration method. I will cover composite section in the class. So for me, for now, for you, composite section will be something which we will do next couple of weeks until the final exam, and pay attention about integration method.